Hey everyone, it's Dr. Robbins. Thanks for watching this short video. I want to begin by giving you a few seconds to check out this picture. So why do you think I'm showing you a picture of Michael Jackson's famous body lean from the video for his song Smooth Criminal in 1987? Have any of you pulled this move off successfully on a level floor like he did? How can we determine if this move is even possible or understand how he actually pulled it off? So the answer lies within our understanding of some basic biomechanics. So the purpose of this video is to provide a brief overview of the biomechanics content within the physical therapy fundamentals course. If you're like most classes, some of you have a very strong background in biomechanics, while others of you may have never even taken a biomechanics class. After all, it's not a prerequisite for a PT school. But biomechanics is foundational for physical therapists to understand how we analyze movement and prescribe interventions for our patients or clients. Given that all of you have taken anatomy and physics, we'll build upon these foundational sciences to develop an understanding of biomechanics. We'll have 18 hours of biomechanics content in this course, plus an exam. Within these 18 hours, we have 6 lectures that are each about 2 to 3 hours long. In addition, you'll have 3 homework assignments and a short 5-minute presentation that you'll deliver to the class on the last day. What I'll do next is just briefly introduce each of these items in slightly more detail. We'll start off the lectures with some basic concepts and an overview of kinematics. This term kinematics is used to describe motion without really concerning ourselves about the forces underlying the motion. We'll develop a common understanding of terminology used to describe motion and cover different types of motion. Starting in the second lecture, we'll start to talk about the field of kinetics. Kinetics is the term that's used to describe the forces that produce or resist the movement we're talking about. The main focus of the second lecture is to establish understanding of exactly what forces are. So we'll review Newton's laws, cover concepts like centers of gravity and bases of support, and begin a discussion of different types of force systems, which is to say, what happens when we apply multiple forces to the same object. It'll be a good idea to bring some scratch paper, a pencil, and a calculator to these lectures. In the third and fourth lectures, we'll expand our discussion about different types of force systems. This will lead us to discuss levers and torque, which is the tendency of a force to produce rotation about an axis. It's imperative that we understand torque if we're to analyze movement, modify movement, and prescribe exercise. Our discussion about torque will start off fairly simplistic, but will move toward an understanding of the true complexity of human movement. If you don't remember basic trigonometry or geometry like sine and cosine, it'll be time to dust it off. In the fifth lecture, we'll switch gears a bit and talk about joint and tissue mechanics. The structure of joints is important if we'll understand how joints optimally move. Physical therapists use this knowledge often when applying interventions like manual joint mobilizations or manipulations. The reason that tissue mechanics are included within this course is because we need to understand how biologic tissue like bones, tendons, ligaments, and cartilage respond to stress or sometimes the absence of stress. Knowledge of these topics help us understand how overuse injuries occur and how interventions like stretching and load-bearing activity affect biologic tissue. Finally, in the sixth lecture, we'll cover muscle mechanics. We'll discuss how the architecture of muscle dictates muscle function, and we'll also review how muscles generate force. We'll move on to cover the relationships between muscle force, the velocity of muscle contraction, and the length of the muscles when contracting. So at this point, I'm going to take a break and move on to part 2 of the lecture momentarily.